Everyone, welcome to the Grand Hackathon of 2025-26, Samved. Samved is a joint initiative by MIT Vishwaprayag University, Solapur and the Solapur Municipal Corporation. I am Preeti Baligar and I will lead you through the problem definition and the early stage architecture expectations for the idea submission stage. So here you see the entire process of the Samved hackathon from the start to the finish. I want to bring your attention to the idea submission stage whose deadline is 20th of February. On this date, you will be submitting to us two critical artifacts, the problem definition and the early stage solution architecture. Let me now describe to you the idea submission stage. In the idea submission stage, you will be submitting to us two important artifacts. One, problem definition, and second, early stage solution architecture. In this video, I shall share with you what is a problem definition and two examples of the same. In the next video, you shall see early stage solution architecture. It is important for you to remember that the clarity of the problem will decide the quality of your solution. In this video, I will share with you one way in which a problem definition can be framed. There could be several other approaches you would be using, but what I am presenting to you is one way in which a problem can be defined. On the screen here, you are seeing the 5 problem statements which were given for the hackathon. Let me now take an example of the first problem statement on the portal. Smart Road Damage Reporting and Rapid Response System for Solapur Municipal Corporation, SMC. You see, this city faces road damage such as potholes, cracks and surface failures due to different reasons such as heavy rains, ongoing construction activities, public utility works and high traffic loads. This has led to serious safety risks, disruption of traffic movement and increased public dissatisfaction. However, at present, our corporation does not have a centralized real-time technology-driven solution for systematic reporting, verification, prioritization and monitoring of road damage complaints across its several departments. Therefore, SMC desires an AI-enabled smart road damage reporting and management system that can enable citizens to report road issues in real time and empowering its officials with tools for verification, prioritization, resource allocation, monitoring and rapid resolution. Several of you would have chosen this problem statement. What next? You will now need to define the problem, which is referred to as the problem definition. But before that, what is a problem definition? Please note that there could be different approaches to frame a problem definition. What we are sharing with you is just one approach. Let me now quickly share with you what a problem definition is and its three entities are. When we define a problem, we always try to explore what the client requires by scoping the problem in terms of three entities. The first one being the objectives. These objectives are the features of the system and generally written in the terms of adjectives and make the object look good in the eyes of the client or the user. Objectives for a typical cell phone are long battery life, good quality camera, clear audio, comfortable to hold with and so on. Next comes the constraints. Constraints are the limits and restrictions imposed on the system's behavior or attribute. These constraints, if violated, make the designs unacceptable to the user and the client. Typical constraints for a cell phone are on the attributes of size, less than say 6 inches, weight less than 200 grams, cost less than INR 25k, battery capacity to last at least 24 hours on heavy gaming and so on. Lastly comes the functions. Functions depict the things the system must do. So typical functions for a cell phone are make and receive voice calls and SMS, connect to internet, capture photos and videos, store them in memory, lock and unlock securely, and so on. Let us now see the first example. The given problem statement is that a cafe prepares fruit drinks and stores them in bottles. Because of increasing demand, the cafe is losing time in capping the bottles before selling them. Therefore, the cafe owner needs a solution to automatically cap the bottles. For this problem statement, the designer needs to articulate the objectives, constraints, and functions so that they can frame the problem definition. Objectives. The objectives of the bottle capping machine are automatic operation of the capping bottle, fast, leak-proof and reliable capping, portable design, user-friendly interface, cost-effective, and so on. The constraints imposed are the volume must not exceed 5 cubic feet. The system must be able to cap minimum 4 bottles per minute. The budget is capped at 10,000 rupees INR. Also, it must use affordable, locally available components suitable for the Indian small-scale manufacturing. Lastly, the functions. The design should automatically cap bottles. It must alert the user after each capping. It must detect liquid level in bottle to prevent under or overfilling capacity. It must position and align bottles for consistent operation, reject or detect defective caps or bottles. So this is an example of a problem statement to a problem definition. You see, consolidation of the objectives, constraints and function gives the problem definition. When we consolidate or put together the objectives, functions and constraints, the problem definition looks like this. But wait, where are the objectives, constraints and functions? With the highlighted color coding, now you can see where the objectives, constraints and functions are in the problem definition. For your problem statement, you would also be submitting to us a problem definition in this form, which will include the three entities: objectives, constraints and functions. Here is a second example of a problem definition from a problem statement. Please note that the earlier one was a mechatronic system, whereas this one is purely a software system. A small coaching institute manages student admissions, fee payments and attendance using paper registers and spreadsheets. However, because of the number of students is increasing, the coaching center owner wishes to go for an integrated student management software. Let me now show you how the objectives, functions and constraints for the same look like. So we have 4 objectives, 4 constraints and 4 functions. The constraints are on the number of active users that needs to be supported, initial deployment cost and compatibility of the system with existing and low-end PCs already available in the institute. And finally comes the deployment time. Again, the consolidation of objectives, constraints and functions leads to a problem definition. Here is again the consolidated view of the objectives, constraints and functions. This problem definition with color coding will allow you to get access into where the objectives, constraints and functions are generally positioned in your problem definition. Please note that this is just one way of carving out a problem definition. There could be several other ways of doing the same. So with this, I want to request you to submit your ideas on or before 20th of February in terms of the problem definition. In the next video, I shall share about the early stage solution architecture. The templates for the problem definition will be made available on the portal. Please note the deadline for the submission. Thank you.